Hi everyone, this is an explanation on how to use embedding layer or embedding module, depends on the deep learning framework. This is a very neat technique that you can use in any kinds of deep learning model or most of the other model learning technologies. As long as you have categorical data. For instance, when you are processing data, you met some data nodes that you don't have much metadata on. It's like you don't have for this data set, you can see I'm using these characters from this very famous novel, which we have lots of names and their relationships, and of course we have some label um, that we visualize as color, but we don't have to use that in this model. What we're doing is when we are having this kind of data, I don't have the gender on the judge, on Javed, on other names. We don't have age. We don't have lots of classical traditional model or learning technology required fields. What we have is just nodes and their relationships, and this is the perfect time that you can consider to use embedding. So for embedding is like a coordination system. Uh, so for embedding, you can see I initialize embedding here. Uh, what we are having here is nothing more than just a two coordinate number for each person. We have 77 person in this data set, and we assign them randomly. We assign them number that were randomly initiated, like two numbers that we can put them on the map. So if you can just look at this map, of course each dots they have their location. Their location that defined by x for this person, like x coordinate and y coordinate, and these coordinates they are randomly generated, like they are just random numbers. So for each dot here, so for this brevet here, it's just a dot that was randomly assigned here. If I try to assign this embedding layer again, it will be putting it might be putting other locations. So that's what we have here as embedding. Embedding is a very simple mechanism. If you put in forward calculation, it's just a mechanism that it will pull you out coordinates. For this task, I assigned we need two numbers to define a point. If you're using it in your own projects, you can just try to use higher number, as two is a perfectly good coordination system that we can visualize as human being, because we understand 2D and 3D things pretty well. For your own good, you can try to use 200 or like 1,000. Will even have much better effects for most of the models. Oh, okay, so for now, we try to define people first as index. As you can see, we can translate a pair of people as like this is number 40's people, this is my number 4's people, and they won't be having any relationships, or they will be having any relationships. I have a logic here says, okay, here, if they have relationship, we will assign 0, and if they don't have relationship, we'll assign the target y as 2. Why is this the case? We'll try to explain that later. Okay, for now, we before the training, we have a randomly assigned map. The training process is just something that we can, move these dots, hence move the coordinate system. More straightforwardly, it's just trying to move these float numbers, like two float numbers for each person. Okay, if we try to pull out the number 59th person, you can see the coordinate is here, and if we try to pull out the number third person, we have something like this, and these numbers will be updated for each person. There will be like more according to their relationships. Okay, now we try not to complicate things. We are not using very complicated model, not neural network. We're just using this distance function that you can maybe you can recall from your middle school or high school, which is pretty simple. And this is how to write this distance function uh, in PyTorch. And let me try to test this function here. If you have 2 points, assume this point is P2, this point is P1, and the distance between 4, 3, and 0, 0 is 5. Right, okay, it checks. Yes, it's 5, and let's move on to the training. So what we do in training is something like, it trains pretty fast. What we do as training is something like if we pull out a random people, which is like a number, unique number we assigned to this people, and try to get out 2 coordinates with this index. So vec1 and vec2, they are just a location, coordinates location, like 2 numbers for each person. So this is 2 numbers, this is 2 numbers for each step, and we calculate their distance. After we have the distance, we match this distance to 2 or 0, as I point out here, like the target y will be 2 if they have relationship, 0 if they won't. So what we are doing here is like this can be either 0 or 2, and we want to move these things, vec1 and vec2, so that the distance and the y can be closer. So let's, after some training, we can try to visualize the first 20 step. Okay, so these arrows, they are painted according to the gradients. If you don't know gradients well, don't worry, it will be handled by optimizer. What we're doing here is just like this point and this point, they don't have relationships. So the gradients like point them to the opposite directions, so they can move away from each other. So on the step 10, let's try to see step 10 and these 2 same people. You can see these 2 same people, they move further away a little bit. So this is just what happens in one step. So for each step, 2 points moved. As like 4 float numbers, 2 points. The 4 float numbers, they're updated according to their relationships. And for now, I'm not using any other data like gender or age or other metadata. We are just using their relationships. Okay, and after some training, after 10,000 times of moving, of that much updating, you can see this location map isn't random anymore. They are more aligned, more clustered together. You see the same color of group, they are more closer together. I have to point out, I didn't use the label, the color label to run the model. I just used them to visualize the tested effect. The effect is like not every color they're clustered together, but most colors they're clustering together, like much more closer. Like you can see for one region, for within one region, these people are more they have higher probabilities, to be the same group of people, and that's it. That's what embedding do. It's like they assign location randomly, and for each iteration of training, they move the points so the locations that can be closer or further, like there are more valuable features. So for most of applications, these numbers, they are very hard to explain. For instance, this for this person, you can see he or she has very low x value, but very high y value. So the location is here. So why is like this number high, that number low? It might be explained if you do look into it, but it will be very hard to explain compared to other model techniques. But the good thing is, even though these things are harder to explain, they are easier to use. for these two numbers for this person, if you input these two numbers into another model, say a model trying to uh, predict what Javed love to watch as movie, or what Fontaine love to buy when she's shopping online, these numbers will mean things. They will try to predict things, with their preference as how they locate in their social map. This is amazing, right? Of course, you can try to run this model, this notebook, which I'll be sharing the Colab link and also the GitHub link, and you can try to run to learn these features that which is more than like a two-dimension of features. You can try to learn 50 or 100 or like several thousands, like most of the big companies do when they're doing collaborative filtering for recommendation engines. Okay, so that's pretty much it. I hope you enjoyed this video.